The concept of the multiverse, also known as the theory of multiple universes, suggests that our universe may not be the only one that exists, but rather one of many universes that make up a multiverse. This idea has been proposed and supported by a number of scientists and philosophers over the years, but it has also been the subject of debate and criticism, with some arguing that it is not a scientifically viable hypothesis. Why does it matter? Knowledge of the answer to the question of whether the multiverse hypothesis is true or not could potentially have significant impact on humanity's understanding of the universe and the nature of reality, as well as on the direction of future scientific research and discovery. How? If the multiverse hypothesis is true, it could provide an answer to a number of questions that have long been debated in the scientific community, such as why certain physical constants appear to be fine-tuned for life, or why the universe appears to be spatially flat. Additionally, it could provide a framework for understanding our universe in a much larger context, as part of a larger multiverse. In addition, understanding the multiverse could give us insight into the origin of the universe and its ultimate fate, and it could also help explain phenomena that are currently inexplicable. Finally, knowledge of a multiverse could help us answer questions of deep philosophical significance, such as the relationship between free will and determinism. Another implication of the multiverse hypothesis being correct is that it would mean that we live in a universe that is not the only one that exists. And if there are other universes out there, then there may be other universes that have different laws of physics than our own. If this were the case, then it would be possible for other universes to be inhabited by intelligent beings, such as extraterrestrials. Finally, it could also bring about revolutionary changes in the way we view ourselves, our place in the universe, and our purpose as a species. Proponents of the multiverse theory. There are several arguments that have been made in support of the multiverse theory. One argument is based on the theory of cosmic inflation, which suggests that the early universe underwent a rapid period of expansion. This expansion could have created bubbles or domains of spacetime that became separate universes, potentially leading to the existence of a multiverse. Another argument for the multiverse is based on string theory, a theoretical framework in physics that attempts to reconcile quantum mechanics with general relativity. String theory suggests that there may be many possible configurations of the fundamental building blocks of the universe, which could give rise to multiple universes. The anthropic principle is another argument that has been used to support the multiverse theory. This principle suggests that the properties of the universe we observe are fine-tuned to allow for the existence of life and the evolution of intelligent beings. Some proponents of the multiverse have argued that the existence of the multiverse could help to explain this apparent fine-tuning, by suggesting that there are many universes with different properties, and that we just happen to observe a universe that is suitable for life. Finally, the many-worlds interpretation of quantum mechanics has also been cited as supporting the existence of the multiverse. This interpretation suggests that every time a quantum event occurs, the universe splits into multiple branches or worlds, each representing a different outcome of the event. This interpretation could be seen as supporting the existence of a multiverse, as it suggests the existence of multiple parallel universes. Some notable proponents of the multiverse theory include Stephen Hawking, Paul Davies, and Leonard Mlodinow, theoretical physicists and cosmologists who expressed interest in the concept of the multiverse. However, they had slightly different perspectives on the concept and its implications. Stephen Hawking was generally open to the idea of the multiverse and considered it a possible explanation for certain observations and phenomena in the universe. He argued that the theory of cosmic inflation, which suggests that the early universe underwent a rapid period of expansion, could potentially lead to the creation of multiple universes within a multiverse. Hawking also suggested that the many-worlds interpretation of quantum mechanics, which suggests that every time a quantum event occurs, the universe splits into multiple branches or worlds, could be seen as supporting the existence of a multiverse. However, Hawking was also cautious about the concept of the multiverse and recognized that it was still an area of active investigation and debate within the scientific community. Paul Davies was also generally open to the idea of the multiverse and argued that it could potentially be a way to explain certain observations and phenomena in the universe. Like Hawking, Davies cited the many-worlds interpretation of quantum mechanics as supporting the existence of a multiverse. However, Davies has also been cautious about the concept of the multiverse and has recognized that it is still an area of active investigation and debate within the scientific community. Leonard Mlodinow was also open to the idea of the multiverse and considered it a possible explanation for certain observations and phenomena in the universe. Like Hawking and Davies, he cited the many-worlds interpretation of quantum mechanics as supporting the existence of a multiverse. However, Mlodinow has also been cautious about the concept of the multiverse and has recognized that it is still an area of active investigation and debate within the scientific community. Overall, while these three thinkers were all interested in the concept of the multiverse and considered it a possible explanation for certain observations and phenomena in the universe, they also recognized that it is still an area of active investigation and debate within the scientific community and that more research is needed to confirm or refute it. Opponents of the multiverse theory. There are also several arguments that have been made against the multiverse theory. One argument is that the concept is not testable, and therefore it is not a scientific theory. Since it is not currently possible to directly observe or measure other universes in the multiverse, and it is not clear how we could ever do so, it is difficult to confirm or refute the hypothesis based on empirical evidence. Some critics have argued that this makes the multiverse hypothesis untestable and therefore not a scientific theory. Another argument against the multiverse is that it does not provide a deeper understanding of the fundamental nature of the universe or the laws of physics. Some critics have argued that the multiverse hypothesis simply postulates the existence of many universes without explaining why they exist or how they came to be. This lack of explanatory power has been seen as a weakness of the concept. Problems with probability have also been cited as a concern with the multiverse hypothesis. Since there are an infinite number of universes in the multiverse and the outcomes of events in those universes are not necessarily connected, it is difficult to use the concept of probability to make predictions about the behavior of the universe. This has led some critics to argue that the multiverse hypothesis is not a useful framework for understanding the universe. Finally, some critics of the multiverse hypothesis have pointed to alternative explanations for certain phenomena or observations that have been cited as evidence for the existence of the multiverse. For example, some have argued that the apparent fine-tuning of the universe we observe can be explained by other factors, such as the existence of a multiverse-generating mechanism, rather than by the existence of multiple universes. Other critics have proposed alternative explanations for the large-scale structure of the universe that do not require the existence of multiple universes. Paul Steinhardt, David Deutsch, and Roger Penrose have all expressed skepticism about the concept of the multiverse, but they have raised slightly different arguments against it. Paul Steinhardt has argued that the multiverse hypothesis lacks predictive power and that it is not testable in a scientific sense. He has pointed out that the multiverse hypothesis relies on the assumption of a landscape of possible universes, each with its own set of physical laws, and that this landscape is not subject to experimental verification. Steinhardt has also argued that the multiverse hypothesis does not offer a clear explanation for why our universe has the particular set of physical laws and properties that it does, and that it is more parsimonious to assume that there is only one universe that exists. David Deutsch has also argued that the multiverse hypothesis lacks predictive power and that it is not testable in a scientific sense. He has pointed out that the multiverse hypothesis relies on the assumption of a many-worlds interpretation of quantum mechanics, which suggests that every time a quantum event occurs, the universe splits into multiple branches or worlds. Deutsch has argued that this interpretation of quantum mechanics is not testable and that it is more parsimonious to assume that there is only one universe that exists. Roger Penrose has argued that the multiverse hypothesis is incompatible with certain aspects of the theory of general relativity, which describes the fundamental nature of space, time, and gravity. He has pointed out that the theory of general relativity suggests that the universe has a beginning, or singularity, and that it is expanding. Penrose has argued that the multiverse hypothesis does not offer a clear explanation for the existence of this singularity or the expansion of the universe, and that it is more parsimonious to assume that there is only one universe that exists. Overall, while Steinhardt, Deutsch, and Penrose have all expressed skepticism about the concept of the multiverse, they have raised slightly different arguments against it. Steinhardt has focused on the testability and predictive power of the multiverse hypothesis, while Deutsch has focused on the testability of the many-worlds interpretation of quantum mechanics that is often used to support the multiverse hypothesis. Penrose has focused on the compatibility of the multiverse hypothesis with certain aspects of the theory of general relativity. While they have all expressed skepticism about the multiverse hypothesis, they have also recognized that it is still an area of active investigation and debate within the scientific community, and that more research is needed to confirm or refute it. The concept of the multiverse remains a subject of ongoing debate and investigation in the scientific community, and there are strong arguments on both sides of the issue. While some scientists and philosophers have supported the idea of the multiverse and have pointed to certain lines of evidence and theoretical arguments in its favor, others have expressed skepticism about the concept and have raised questions about its validity and explanatory power. Ultimately, the question of whether or not the multiverse is true is a complex and multifaceted one that is still the subject of ongoing investigation and debate.